Okay. So what we're going to eventually do is we're going to look at the relationship that the 30, 60, 90 triangles have on the angle measures in the unit circle. Okay, because there is a direct correlation. Okay. All right. So first of all, the unit circle is a circle that is 1 unit long. So what we're going to do is we're going to do it on this axis here. We're going to go ahead and draw ourselves a nice little circle. Okay. And basically the idea of a unit circle is that it is exactly 1 unit long, whatever that unit is, from the origin out to the edge of the circle. Alright, so and then I'm going to go ahead and I'm going to draw a random angle here. That's my random angle. It's not, I'm trying to make it a little straighter than mine. And there's my random angle. And we're going to relate that angle to a triangle. Okay, so I'm going to drop down a leg here. Can we see how I just created a triangle in there? So that is what we call the reference triangle. Okay. And I can label my reference triangle a little bit. And you have 3 standard reference triangles: a 30-degree triangle, a 60-degree triangle, and a 45-degree triangle. Okay, so those are our typical reference angle measures for the units. Okay. In general, when we talk about a circle, we call that the radius of the circle. Okay. Across from the reference angle here, this is a y, going in the y direction, right? It's vertical, so I'm going to generically call that one y, and call this one x. And even though we're using this angle here, is what we're probably really finding the ordinary or the mid or the trig form, we're going to use that reference angle, or that reference triangle. Alright, so let's talk about what it says about trig functions. So trig functions of an angle in standard position. For any angle in standard position with measured data, a point pxy is on the terminal side and r equals this. Really what this is saying, back in geometry you learned the equation of a circle. Okay? All this was the equation of a circle, right? Because all they did was take the square root of both sides. Okay? Equation of a circle of when it's centered at 0, 0 is x squared plus y squared equals the radius. Okay? So the trig functions are as follows. Alright, so all they want us to do is take this reference triangle, find a sine, cosine, tangent, cosecant, secant, cotangent. We were doing that before break, right? So if I'm using this reference angle here, what's the sine ratio of that triangle? What's your opposite leg? Y is your hypotenuse. Alright, there you go. Y over R. That's all I'm looking for. Is it in variables? Okay. Alright, what's the cosine of that triangle? Adjacent over hypotenuse. Okay, what's your adjacent? X over R. All we're doing is what we did before break, but now doing it other way. Okay? Okay. Alright, tangent. What's the tangent of that triangle? Okay, like opposite over adjacent, what is the opposite? Y over X. How do I get the other 3? I can just flip them, right? So I have R over Y, R over X, and X over Y. Okay? So basically what that's telling us is we can use this reference triangle, find the sine, cosine, tangent of any angle on the unit circle. Okay? Alright, so we're going to learn some really, really super basic trig identities next. Okay? If you look up at the windows, okay, so if you look on either side of the room, so whichever direction you're facing, you should be able to see it. Okay? There's a yellow column of signs and a purple column of signs. I know the purple one's harder to read, but eventually we can memorize that one. What we don't get used to. So there's what we call the reciprocal identities and then the quotient identities. And we're going to do them again, but for our purposes today, we need to know there's 3 or 4 of them we need to talk about. Okay? Obviously, those things are on the walls. Okay? Eventually, they should become internalized, and you should have some kind of memory of them. But they've been on the walls all year. rest of you. Okay? Don't need to worry about them coming off the wall. So the cosecant, the reciprocal of cosecant, we kind of already know this is sine, isn't it? So when we want the reciprocal of cosecant, we do 1 over sine. I'm being really lazy. I'm not putting the betas or the x's or anything. What's the reciprocal of secant? Cosine. So 1 over cosine. Okay. So if I have the sine value, all I have to do is put 1 over the number, or reciprocal the number, right? I get cosine. Okay. All right. Tangent. The reciprocal identities don't work because the unit circle is going to be in terms of sine and cosine. Okay. So I need to relate tangent and cotangent to sine and cosine. Tangent is the sine divided by the cosine, and the cotangent should be reciprocal, right? Cosine divided by the sine. All right. So we have to talk about the quadrantangles first, and then I'll teach you the triangles. Okay. The quadrantangles work a little differently. What I mean by quadrantangles are the ones that are the 0, the 90, the 180, and the 270. They're on the edge of a quadrant. They're on the axis. Okay. So if you hit one of those, they have to they're going to act a lot differently, okay, than the other ones. Okay. So we're going to use this chart to begin with. Sorry, my stuff is on top of my chart. My questions are on top of my chart. But we're going to use this chart to start with, and whatever I do for 90 is the same as pi over 2. Okay, because they're cosine. All right, so I'm going to start with the sine. So there's another thing you need to know. I don't know if it's in your notes or not. Is that cosine comma sine there? Okay. So notice I labeled the axes with the coordinate that they would be, right? Because if it's a unit circle, it's 1 out, 0 up. This would be 0 out, 1 up. Does that make sense? Out negative 1 up 0, out 0 down 1. Okay? So the coordinates relate to the x coordinate always represents your cosine, the y coordinate always represents the sine. Okay? So whatever's in the x spot is the cosine, whatever's in the y spot is the sine. So if I ask you to find the sine of 90, we're looking up here. I want you to read me the number that's in the y spot. What is it? 1. If you put sine of 90 into your calculator, and it's in degree mode, you get 1. Okay? Alright. I'm going to go to the y spot for 180, so I'm going to go across. Okay, so what's in the y spot for 180? 0. Good. What about the y spot for 270? Good. What about the y spot for 360? 0 again. And you're going to see some patterns. Right? Alright, the cosine of 90. So is cosine the x spot or the y spot? The x spot. Okay, so in 90, what's in the x spot? 0. Good. What's in the y or the x spot for 180? Good. What's in the x spot for 270? What's in the x spot for 360? Perfect. Alright. We just learned that tangent is the sine divided by the cosine. This is why, because we know the coordinates, we know the number for cosine and sine, but we don't know any of the others, right? That's why I needed to relate everything to sine and cosine. I needed to find that relationship. So all I'm going to do is take the sine and divide it by the cosine. So here I would have 1 divided by 0. Uh-oh, am I allowed to have that? No, so what would we write? Remember the word? It's undefined. Okay, you can abbreviate that. I'm writing it out for you. Okay, and again, sine divided by cosine again would be 0 this time, wouldn't it? 0 divided by a number is okay. I just can't have a 0 on the bottom. Alright, then I'm doing sine divided by cosine again for 270, and I end up with undefined again. So undefined is a common thing to get. Okay. Alright, and then I get 0 divided by 1, which is 0 again. Alright, let's look at the cosecant. What was the cosecant the reciprocal of? Sine. So I'm going to go to the sine and I'm going to flip the sine, right? So what is 1 it is undefined. The bottom four are always going to have some undefined. Okay? The tangent, the cosecant, always have undefined. Okay. All right. Secant. So is the reciprocal of what? Cosine. Good. It's the reciprocal. So now we're going to do the reciprocal of 0 and we get what? Undefined. Good. What's the reciprocal of -1? Good. Do I really need to write down 1 divided by 0 again? What are we going to get for this one? Undefined again. Okay. What's the reciprocal of 1? All right. This last one, and again, I apologize. Let me write it in different colors. All right. Cotangent we learned is the cosine divided by the sine, or I can flip what's in the tangent, right? So it's up to you. So this one's going to be 0 divided by 1, which is 0. Good. All right. The next one would be -1 divided by 0, which is undefined. I have 0 divided by -1, which is 0. And then the last one would be 1 divided by 0, which is undefined. Okay. Alright, so before I get into the next little activity, okay, the next thing else, I want you to look at your unit circle and then explain it for me. Okay? So that's what your unit circle looks like, and that we built yesterday. I want to look at the orange ring. Okay? And remember, our angle is not on the unit circle that we see. You can always add or subtract 360 or 25. Okay, so remember how we did that before, right? We added and subtracted 360 to find or to find a little bit. Your angle's not on the unit circle, that's what you gotta do first. Okay? Then we need to determine what quadrant it's in. So out here it tells us which ones are positive or negative in each quadrant. Okay? So in quadrant 1, every trig ratio is positive. So they're all positive there. Okay? The only ones that are positive in quadrant 2 are sine and cosecant. So what does that mean about the other 4? They're negative. Okay? So in the quadrant 2, the only ones you can write positive are sine and cosecant. Everybody else is negative. Okay? In quadrant 3, it tells us that tangent and cotangent are positive. So what does that mean about the other 4? They're negative. Okay? In quadrant 4, cosine and secant are positive. What does that tell us about the other 4? They're negative. So the way that I remember that with the mnemonic device is all students, because S is for sine, right? And it's the reciprocal, right? That's what it is. So all students take for tangent and C or calculus, C for some teachers classes. Alright, so my subliminal message. Okay, so what we're going to use that orange ring to answer the next few questions. We're going to use that orange ring and we're going to use our chart. Okay? So, if you hit one of the ones that's on the axes, you're going to go to the chart. Okay? If we hit anything else, we're going to use the orange ring. Okay? So all the question is asking us is to decide if it's positive, negative, 0, or undefined. Okay? So, where's the first one they give us? Sine of 135. Negative 135. Is negative 135 on our unit circle? Positive 135 is negative 135 here? No. So what do I need to do to get this a coterminal angle? What do I add or subtract? What's one full revolution, guys? I just talked about it. 360. Okay? So when I add 360 to negative 135, we really get the sign of what? Good. It's 225 on our unit circle. Okay, what quadrant is 225 in? We're in third quadrant. 225 is right here. Okay? It wants me to find the sine. The only things that can be positive are tangent and cotangent. So it's the sine of the sine, S-I-N. Okay? Is it going to be a positive or a negative? It's going to be negative. write down a negative. That's the answer. There's not a lot of written work today. There's a lot of thinking about my work. Okay? Alright, is 405 on our unit circle? Now, how do I get to something on the unit circle? Minus 360. Alright, so I'm really looking at the cosine of what? 45. Perfect. What quadrant is the cosine of 45 in? 1. And if you should be on your unit circle following this, so you understand how to do this. Okay? So cosine of 45 is in quadrant 1. What do we know about all the, is it positive or negative in quadrant 1? Everybody's positive, right? So positive is my answer. Alright. 315. What quadrant is it in? 4. Okay? In quadrant 4, is tangent positive or negative? Okay. Alright. Cotangent of 2 pi. What quadrant is it in? It's on the line. So what am I supposed to do if it's on the line? Go to your chart, right? And eventually you're not going to need the chart. We'll wean you off the chart. Okay, so we're going to go to the chart, cotangent of 2 pi. What do we know about cotangent of 2 pi? It's undefined. So we're going to write undefined. So this said positive, negative, 0, or undefined, or possibilities, right? Okay, let's do this in gradients a little bit. And I'll probably do 2 more together, and then I'll have you try the last 2 on your own. Okay? Alright. What quadrant is pi over 4 in? Quadrant 1. Okay, in quadrant 1, is cosecant positive or negative? Perfect. Alright. 11 pi over 4. Is that on our unit circle? No. Okay? So I either have to add 2 pi or subtract 2 pi, but I want to be 2 pi that's in over 4 world. So what would 2 pi look like in over 4 world? Good. So we've got the secant of what for them? 3 pi over 4. Perfect. What quadrant is 3 pi over 4? Okay, for the second quadrant. Everybody found it in the second quadrant? Report in the second quadrant. Okay? Is secant in the second quadrant positive or negative according to your tree? Negative. Alright. I want you to try 7 and 8. I'm going to give you about a minute because it shouldn't take me that long. Okay? Another 20 seconds. Okay, which quadrant is 19? It's okay, it's not in a quadrant, right? It's a quadrant angle, right? So what did we say we got? Undefined for tangent. Okay, good, because you had to go use your chart, right? Okay, what do I have to do first to the negative 45? Add 360, good. So cotangent of what am I really looking at? 315, what quadrant is 315 in? Fourth quadrant, good. Okay. So fourth quadrant is cotangent positive or negative? Negative. Okay. Okay. Let's look at the next part now. Okay. So now what they're wanting me to do, okay, because they want me to find the exact value. In this section here, unfortunately, I don't have a degree up to add or subtract 360 or add or subtract 2 pi. Probably going to have to do that on the norm. Okay? So just know that this part here is going to turn up in the norm. So we have to do that first. Okay? I'm going to teach you the basic of how to do this. Okay? So, cosine of 150. We're going to look at our sign, our operational sign first. So the positive or the negative. That's where I always start. So just like what we did in the last few examples. So, cosine of 150, what quadrant is 150 in? The second quadrant. Everybody found 150? Make sure you locate it. Here's 150. Okay? Now we're looking at cosine. So is cosine positive or negative? Negative in that quadrant. So I'm going to write that down first. Now it wants you to find the exact value. Okay? That means I need to do SOHCAHTOA. Okay? So what I'm really looking at is cos, right? Cosine. So this is where the lines and the triangles come in. Okay? What color is the line that 150 is on? Blue. What reference triangle would I be using? The 30, the 45, and the 60? The 30. See how they're color coded? Yeah, I did that purposely. Alright, so this is the reference triangle I'm going to do SOHCAHTOA on. Okay? So, what is the adjacent leg? Square root of 3. Good. What's the hypotenuse? 2. So that's what I'm going to write down. I'm going to write down that ratio. Square root of 3 over 2. It looks like we did no work, right? All I did was write an answer. That took us like 45 seconds to a minute and a half to do, right? There's a lot of thinking behind what we're doing right now. Okay, just not a lot of written work. Okay? That doesn't mean just copy the answers when you see them. Okay? You need to try it. Because if not, you're gonna get this could be a really awesome test score, but you gotta know what you're doing. Okay? Alright. 135. So what quadrant is 135 in? Second quadrant. Okay. In the second quadrant is cosecant positive or negative. Even though it's redundant to write that plus sign, I do it. Because then I know I took care of looking at it if it was positive or negative. Okay? Alright. So 135, we said it's quadrant 1. What color is 135? It's red or pink, right? The red has to go with the pink, because that's what we have. So, and we were doing cosecant. Cosecant is CHO. So what is the hypotenuse of the pink triangle? Square root of 2. Awesome. What was the opposite of the pink triangle? 1. Alright, so we've got square root of 2 over 1, or couldn't I just write square root of 2? Alright. 240. Where is 240? What quadrant? Third quadrant? Okay. In the third quadrant, look at your orange ring. Is sign positive or negative? Negative. Good job. Alright. What color is it? So green overpowers blue. Okay, so if it's the green line, it's a green. Okay, so this is the one we're looking at. So we're going to look at our green 60-degree triangle line. Is not Alright, so, and we're doing the sign. So I have so. So what is your opposite leg? Square root of 3. What's your hypotenuse? 2. Notice how our answers are going to be a lot. It's going to happen. Okay, there is a pattern. Okay? And I will show you the pattern eventually. Okay, there's another way to do this without the triangle. Okay, so we're just learning the triangle. Okay. All right, good with example 11? Okay, let's look at 12. So, 5 pi over 6. It doesn't matter that I flipped it into radians. Okay. 5 pi over 6, what quadrant is it in? 2. Okay, so in quadrant 2 is tangent positive or negative? Okay, negative? Okay. So let's go to, so what color was the 5 pi over 6? Blue. Alright, so blue. Alright, and we needed to do tangent, which is TOA. So I'm going to use the blue reference triangle. over, right? Because radical 3 times radical 3 is just the number of pieces, right? Again, we're going to see that number. Okay. All right, let's look at example 13. Okay. All right. All right, what quadrant is 5 pi over 4 in? Third quadrant, good. Where is cotangent positive or negative in the third quadrant? Positive. Again, I'm going to write that down. Okay. What color is it? It's red or pink. Okay, so I'm going to use my 45-degree reference triangle. And let's see, we're doing the cotangent. Cotangent is cow, right? So what's your adjacent leg? 1. What's your opposite leg? 1. So 1 over 1 is going to be 1 over 1. Right. Oh, good. We do get one that's not on the list. Okay. There'll be probably more than just the one here. Okay. All right. So is this one on the unit circle? No. Okay. So I have to either add or subtract 2 pi, and if it was in degrees, what would I add or subtract? 360. And we saw that earlier in the lesson with the other ones, right? So I'm in over 3 world. So instead of 2 pi, what does 2 pi look like in over 3 world? Good. So we're really going to find the secant of what? 2 pi over 3. Perfect. Okay. Which quadrant is 2 pi over 3 is? Second quadrant. Is secant positive or negative in the second quadrant? It's negative, isn't it? Because only sine and cosecant are positive. Secant is negative. Okay. Alright. I'm going to look at Sha, right? What color is this? Green. Okay, so everybody's looking at your green reference triangle, and you're looking for your hypotenuse and your adjacent. What's your hypotenuse? 2. What's your adjacent? 1. So it would be negative. All right. line on your pink triangle? 1. Good. What's your opposite? Also 1. Okay, so it should be -1 was your answer. All right, good. Okay. Secant. All right, so 2 pi over 3 is in which quadrant? Second, is secant positive or negative? Negative, good. All right, and then what color is it? Green. Okay, so we're doing Shaw on the green triangle. What was your hypotenuse of the green triangle? 2, what was your adjacent? So -2. Okay, all right, last one. All right, the cosine, so 11 pi over 6 is in which quadrant? 4th. Okay, is cosine positive or negative? Positive. Excellent. All right. I need to do what color is it? Blue. So blue is my reference triangle. It's the adjacent leg on the blue. And what's the hypotenuse? 2. All right. All right. So I'm going to stop there. There is a worksheet posted on Haiku. You have a lot of time left. You should do it right now. Remember, if it's not there, add or subtract 360, add or subtract 2 pi. There's one that's like crazy like this. Let's talk about this really quick. Something like a really big odd number. So it was like, I don't want to do 80, so let's say like 75 pi. Think about this, okay? If this is 2 pi and this is